So now let's talk about how can you create tables in MySQL or like mostly the RDBMS. Now the important part about creating a table is not the syntax of how to create a table. Now we talked about the fact that RDBMS have a strict schema. Having a strict schema means that what all columns are going to be there and what is the type of every column. Every column is going to have a type. For example, let's say if I do use LCO films and then I do describe film and let's say I run this code. Can you see it describes me how the overall film table looks like? Now if you carefully see, this field property represents the column. This represents the column. And correspondingly, there is a type. Every column has a type. And you can see there are a lot of types. There is some text, small int, tiny int, timestamp, lot and lot of data types are there. It's similar to the data types that you have in your programming languages. So every RDBMS, let's say if you're using MySQL, there is a chance that MySQL might support some different set of data types. There is a highly likely chance that if you use PostgreSQL, then it might support some more type of data types, things like that. So you can search for data types in MySQL specifically. Okay. So you can go to the official doc. These are the official doc, dev.mysql.com/doc. Okay, so you can see these are the different data types that comes into the picture. So there are a bunch of numeric data types. Okay, so let's see some numeric data types. So you can see that there is integer, small int, decimal, numeric, float, real, double precision. There are a lot of different data types just to incorporate your numeric values. So let's say at any point of time you want to store some decimal values, you might use some double. You want to store some small decimal values that are not of very long range, then maybe float is good, right? So you can read about like in small int is going to be storing very limited number of integers. For example, if you open small int, then you can see there is a difference. Small int takes 2 bytes in your memory. So if you have a column of small int, then every entry of small int is going to take 2 bytes of the memory. Tiny int is going to take 1 byte. Medium int is going to take 3 bytes, so on and so forth. And then you can even see the range. If you have a small int property, then the minimum value that you can store is negative of 32768, and the maximum value that you can store is 32767, right? And that to signed value. That means you can have a tiny int, small int that is signed or unsigned. Signed or unsigned means that when you have a signed small int, then it will also incorporate negatives and positives. But when you have unsigned, then it will only incorporate positives. So when you have unsigned value, then you do not have any negative altogether. So then the maximum positive value can go here. So you can see every data type has a range altogether. Now it's up to you that you will decide which column property is going to be of what value. Now, for example, let's say that any commodity, if let's say you are building an e-commerce, any commodity, or let's take an example for our case of our movie thing, right? If you carefully see, then the rental rate is a decimal value. Can you see a rental rate is a decimal value? Let's open the details about decimal. Okay, so let's open the detail about decimal, how much space decimal and all takes, right? So okay, you can see this is given. Now you can see this is the range of decimal that can be stored, right? So you can read more about it. So the thing is that what type of data type you are going to choose is going to be dependent on many factors. For example, in an e-commerce, I don't think there will be any product that you are going to sell on Flipkart that will be of this big value, right? I don't think on Flipkart there is any product that is sold which is of this price. Maybe it is of still this price. Still this price is still doable, right? But I don't think this price is something that is sold on any product is sold on Flipkart. So there is no point of spending 4 bytes for storing that same value that could have been stored inside 3 bytes. Every like if you see at a scale of Amazon and Flipkart, these bytes are going to actually contribute a lot in terms of storage space, right? Lesser storage space means lesser cost. So this is something that you have to always keep in mind. So there are a lot of data types to actually store numerics. Apart from that, you can see apart from numerics, there is date and time data type. Okay, there is a date and time data type. So you can see you can store date, just the date and time, just the time, year, timestamp, a lot of things you can actually store, and you can read more about it. Like let's see how timestamp looks like. So if you carefully see a timestamp value, this is how correspondingly a timestamp will look like. right? So you can read more about it. Apart from that, there are decimals that you can, sorry, apart from that, there is string data type. Now this is very interesting. In SQL, generally, strings are referred as varchar or char, right? For example, so if you go to string data type, so the string data types are char, varchar, binary, var binary, blob, text, enum, set. These are the different types in which you can actually store string. Okay, so let's say open varchar. What is varchar? So char and varchar. So in char and varchar, you can actually define that up to what limit, like how many characters will be there in your string. So if you put a varchar, there will, you can actually give, let's say in my string there won't be ever more than 30 characters altogether. So that's where you can use varchar. Whereas let's say if you use something like text, right, blob and text. So blob is a binary large object that can hold variable amount of data. The four blobs are, the blob has also subtypes: tiny blob, blob, medium blob, long blob. These only differ on the maximum length of the value that they can hold. The text types, different text types are tiny text, text, medium text, and long text. These correspond to the four blob types. So you can see, even to store text, there is a lot of different ways to actually store text. So it's not that simple that in JavaScript, if you see, there are 7, 8 types, generally null, undefined, let's say, then you have numbers, then you have strings, right? Then you have objects, right? And what else? Yeah, and Boolean. These are mainly the overall type. Then you have big int also and symbols. That's it. But here you can see in types, there are subtypes as well. So there are a lot of data types that MySQL actually supports. Now, I believe in your whole life with MySQL, SQL, whatever SQL you are using, you should not spend more than 10 minutes in going through the documentation of data types, because there are so many data types. There is a highly likely chance that there will be a lot of data types that either you will never encounter or you don't need to bother what they do, right? Whenever you will need to do something, you can just quickly Google it and know. But it's good that you know about the uber level data types, that okay, there is a string, there is a JSON data type also. For example, let's see this JSON data type. If you want to store a JSON, okay, so how do you do that? Let's see if there's any syntax given. So this kind of a JSONs you can actually store in MySQL, right? So let's say create, so I'll tell you this create table syntax as well. And there is a property JDoc, there is a column JDoc which is of type JSON. So you can actually store JSONs here. See, right? So you can read more about it. So for example, select JSON type, right? So JSON is a very interesting object. Maybe we can spend more time just with JSON if let's say at any point of time you want to learn about JSON. But my point being that at any point of time there won't be a situation that anyone will ask you that, oh, what all data types exist with MySQL. If anyone is asking, like, to be honest, not even in college, people used to ask a lot about data types in SQL and everything, because this is absolutely something that you don't need to remember at all if you're a software engineer. So I would recommend you guys to just go through the docs once for like maybe 5 to 10 minutes, and see what all data types are there, and then start like just using them, right? Start using them. You can read a lot of details about different tables of the database that you are actually being involved with, and then you'll understand, okay, there is a year type also, there is something called as an enum also, that is a set of strings, right? Then there is small int which is unsigned, timestamp is there, varchar is there, and then maybe you can read about it. Or when you have a use case, when you have to, let's say, create a table, then you can maybe read about it. Now let's try to actually use whatever knowledge we just got up till now, and let's try to prepare some tables altogether. Okay. So now creating tables is not that of a difficult task, but generally I've seen that if you generally work somewhere, then it's not that you are daily going to create a brand new table altogether. Generally, when you start a product, then at least on the architect level, people actually think how the database should look like and everything. And generally on the start only, you create a bunch of tables altogether. Right. But still, if you want to create a table, how things should actually look like. Now, creating a table is fairly easy with MySQL or like most of the SQLs. The command looks something like this: create table. So if you want to create a table, you write create table. Okay. Then name of the table. So let's say name of the table I'm keeping as, let's say, theater. Okay. For example, I'll delete this table of course later. Right. Name of the table is theater. Then what you do is, and I'll put a comment here as well. So you write something like, to create a table, we do create table, table name. Okay. And let's do it like this, table name. And then what you do is, inside a pair of parentheses, right? What do you write? You write column 1 name and then type of column 1, then column 2 name, and then type of column 2, right? And so on. So actually define what will be the name of the column and what will be the type of the column. So for example here, let's say we are going to keep something like this, that every theater is going to have a name. And let's say theater name is not going to be, let's say, of more than 50 characters or 60 characters altogether. So we can keep something like a varchar. Okay. Let's say I'll keep varchar 50, something like this. Okay. Varchar 50. Then let's say a theater will be having, let's say, some description. Okay. Now description can be a pretty long text. So I'll say, I'll just put a text altogether, right? And let's say that's it. Let's say that's it. This is what you can actually do in order to prepare a table. So let's execute this file. So currently, if you see what all tables are there, these are the tables that I already have in my LCO films database. If I execute this file, you can see create table executed successfully, right? And if I refresh, can you see there is a theater table now coming up? As simple as that. That's how you can actually create a table. Now let's say if you want to delete the table that you created, right? That's also a pretty easy affair here. Just like how you delete a database using drop, you can say drop table theater. And this is going to delete a table, right? So if you just execute this, now you can see the theater table is gone. Okay. Generally, there is a good practice. Generally, there is a good practice for creating a table, that you say create table, and after that you write a condition that if not exists, that you can create a table theater if a table of the same name theater does not exist, then you can actually create it. So this is generally a good practice to go for. So if you execute it and refresh, now you can see again there is a theater table back, and you can just drop the table just like that. Okay, cool. Now, apart from just giving the, I would say, column name and the column type, there can be some more properties that you can actually give. For example, you can actually give some validations to these columns, that this column should follow a particular validation. For example, theater name can never be null. It can never be empty, or like it can never be null value, right? So you can say that it should be not null. So apart from column name, type of column name, then you can actually put some attributes. Okay, you can give some attributes kind of stuff. So kind of like you can put not null, that this column can never be null. Okay, so if I execute this, if I just execute this part, okay, you can see uh, table created, we have theater, right? And if I do describe theater, right, if I do describe theater, can you see name is varchar, description is text, but on the null part, name says no. Name can not be null, description can be null. Kind of like that. Okay. So this is something that you have to keep in mind, that how you are managing this thing. Now, for example, to uniquely identify every theater, I'm going to give a theater ID also. So let's say I give a theater ID, kind of like that. Now, let's say theater ID is going to be kind of like an integer. Okay. Now, if I just do this, what will happen is I will create a column ID which will be integer. Now we have to give ID ourselves. So whenever we will insert a new theater, we have to not only just give the name and the description, we have to give an ID also. To resolve this, there is an attribute that you can add as auto increment. Auto increment that you can add. So let's drop the table. We drop the table, and now let's create the table. One second. Okay, it throws some error. Let's see what error it is. Incorrect table definition. Okay, let's see. Okay, so I guess there is an int type. Let's quickly check the numeric type. Do we have int? Oh, sorry, this is integer. My bad. Not int, integer. Okay, now let's execute. If I run this, Okay, still it has some problem. Right, okay, let's first of all do without auto increment. Let's try with without auto increment. Okay, now it created. I'll show you there is one reason most probably that auto increment is not working. Okay, now if I do describe theater, okay, now you can see ID is int as well. But again, what happens is you have to give manually the ID. For that reason, I was giving auto increment. Okay, I was giving auto increment. Okay, cool. Now the moment you start giving auto increment, it start creating problem. Sorry, the table already exists. So let's drop the table, dropped it, create the table again. And now you can see it creates a problem. So let's, what do? We just Google it. Auto increment in MySQL. Okay, let's see. So auto increment attribute can be used to generate a unique identity for new rows, right? So you can see this ID is given medium int, not null, auto increment. Okay, and let's see anything else. No. So let's see. Now they are giving not null also to ID. We will also give not null to ID. Okay, let's try now. Most probably it will still fail. See, it's still failing. Why? There is a reason. There is something called as a primary key that we are expected to add. Okay, let's see. I'll tell you about what is primary key, but let's say at the very last, okay, at the very last after description, I will add a primary key, and let's bring this in new line. Okay, so you can bring your query in new line very easily. Okay, because terminal character is a semicolon, so you can write like this. Okay, so this is our syntax. Now let's try to create it, and this time you can see it actually got created, right? So there is something called as a primary key that we have to do with the auto increment. So you can actually Google about, like, I'll teach you about keys, but why auto increment doesn't work without primary key. You can just quickly read about it. Okay, so you can see it is not necessary to set a primary key field for as a auto increment. Only constraint is that it should be unique and not null. So primary key automatically makes that particular part unique and not null. So that's why just giving not null was not helping. But maybe if we can give unique, then it will help. So let's see how to make a column unique in MySQL. Okay, how to make a column unique. So in MySQL also, a lot of time when you will search for something, no, W3 Schools is a very bad website, to be very honest. It will give you SQL syntax. I've already taught you about the fact that there is a SQL standard, and every RDBMS has opted for SQL standard and modified something. So there is a chance when you see SQL unique constraint, there is a chance that this may or may not work in MySQL depending on whether MySQL has adopted or not. So always search for MySQL syntax or PJSQL syntax if you're using PJSQL, rather than relying on SQL syntax, because SQL is a standard. I'll during joins and everything, I'll show you that some of the syntax that they mention here will not work in MySQL. Okay, so let's see. So you can see there is a unique property that we can add. Let's try it. So I'll drop the table theaters. You can see we dropped it, and instead of giving a primary key, let's say instead of giving a primary key, we will give a unique constraint. Okay, let's try now. Let's run it, and this time you can see it created. So it has to be not null and unique. So primary key automatically makes it both. What is primary key? You don't need to worry as of now, but you can see we sailed our way through. This is how you can actually create a table altogether. And there are a lot of more properties that you can actually add, but you don't need to know all of the properties initially. You can actually get started with a few things, and then you can actually tag along yourself with all of that particular data. Now let's see how we can actually insert some data inside a table that we just actually created, right? Now inserting data is going to be relatively very simple, right? So how do you insert data? So there is a syntax called as insert into. So in insert into syntax, you have to first of all tell the table name that you are inserting into a particular table. And then you put a pair of parentheses defining the column one name, the first column that you are inserting, second column that you are inserting, and so on. Then parenthesis closes, and then you have to write values. And then in the same order, let's say you wrote column 1, column 2, column 3, and then in the same order, you will give value for column 1, value for column 2, comma separated, and so on. This is how you actually insert into table. So let's see. So for example, I'll say insert into theaters. I'll refresh here so that you can see theater here. Theater. Okay. Now what are the two columns? One column is a name, one column is a description. Okay. I'll say values. I don't need to give ID because ID is auto increment. I'll show you in a moment. So let's get some theater names. Okay. Let's write it like this. Let's say PVR Shanti Niketan. Okay. And let's say we'll say some description. Okay. Something like this. If I execute this code, can you see it inserted? So if you have to check what all got inserted, select star from theater, run it, and you can see automatically it gave it a ID 1, PVR Shantiniketan, some description. So if I copy and paste it again, and let's say this time I say PVR Pacific, right? And let's say execute the second insert command and then call select. Can you see automatically it got the ID got incremented to 2. But this looks a bit cumbersome, right? Also before that, now let's say I do one more insert command. This time I will first push this description, then I will put the name. So in the same way, here also you have to first give the description. So in the order of whatever column order you have given, in the same order you have to give values also. So some description for Phoenix goes here, and PVR name, let's say I say PVR Phoenix. What's the spelling of Phoenix? Phoenix, right? Yeah. So now if you insert and select again, can you see still PVR Phoenix went into name and this got to description, because the order in which you will mention the column, in the same order you have to add the values. Now let's say if you have to want to add multiple values, because you can see insert into, that will be cumbersome, right? So if you have to do a bulk insert, what do? You use the same command altogether, right? But this time after values, you put multiple pair of parentheses, comma separated. So the first pair of parentheses are for value 1, second pair of parentheses are for val2 call 1, val2 call 2, then the third pair of parentheses are for val3 call 1, right, val3 call 2, and so on, right? Something like this. So let's do that. So I'll insert again. This time I'll do a bulk insert. I'll put it in new lines. So insert into theaters, values. So and let's put name first, then description. Okay. Now let's put something. So let's say I'll say Cinepolis Shanti Niketan. Okay. Then I'll say some ABCD for the description. Then what I'll do is I'll put a comma and then I'll put another pair of parentheses, right? So this time, let's say I will add PVR Sanket. Then in description, I'll write something. Then comma, let's say one more. This time, let's say Inox Janakpuri. Then something. Right. So this time, in one insert command, I'm trying to add 3 values, right? If I'll and you can again segregate it into multiple lines, because in a SQL statement, the moment semicolon comes, that's an end of a statement. If you want to put things in new line for better visibility, you can put. So now let's execute it. You can see it successfully executed. If I do a select star now, can you see now below PVR Phoenix, you have Cinepolis, PVR Sanket, Inox Janakpuri. So that's how you can even do bulk insert inside your tables altogether. So the script that I actually asked you to actually use to get the whole DB dump, if you will open that script, no, then you can now actually start reading the script. For example, you can see here they created a table actor. Then the property was actor ID, first name, last name, address ID, last updated. These are the data types and these are the different attributes. Then to insert into actors, these are all the data that they inserted, again using bulk insert. In one insert command, they have added almost what? 200 odd actors, right? So similar kind of a command that script also uses. So now what you can actually do is you can actually try doing the insert statements. These are pretty handy, but generally, of course, when you are actually doing some production level coding, then you don't have to write SQL queries to add data. There will be dedicated APIs that will be pushing all of this code. But still, if at any point of time you have to do any kind of a raw interaction with your SQL database, this is how you can actually do it there. So now let's say we have a problem in front of us. What's the problem? The problem is that we are going to calculate the number of films which were released in the year 2017. Okay. Now you might feel that, okay, if we have to get the number of films year released in year 2017, that should be a relatively easy task, right? You can do like LCO films, right? Just a shorthand to write this should be like select star from. If you don't want to write that, use LCO films again and again. You can say LCO films dot, you can say DB name dot table name. So film, it will automatically show you recommendation where, let's say, release year is equals to 2017. Maybe you'll do something like this, right? But this is not going to give you actually a count. This is going to give you all the records which were in 2017. You need to get a count. Count is more or less like a summary, right? That you want to summarize the data. Whenever you have to do kind of like any kind of like a summary of your data, there is a clause called as group by clause, right? What's the use of group by clause is that like it actually helps you to summarize stuff. It actually helps you to group a set of data and then work on the common properties of that data. For example, what is the common property among all of these data that we filtered out with where clause? The common property here is that all of them are released in 2017. So the group by clause will help us to target the common property altogether, right? So you can actually group rows, right? So instead of saying something like this, we'll say group by release year. Okay, if you do group by release year and instead of star. So now what happens is SQL also provides you kind of like some aggregation methods that whenever you have grouped something, so on that whole group, if you want to apply a particular thing, you can do that. So for example, I'll say something like count star. Okay. What count gives us is that group by is going to take all of your films which were released in any release year and group them based on release year. And then on each individual group, you are going to apply a count. Let's first of all see the output and see how it looks like. Can you see? It is showing us a lot of counts, 44, 24, 100 and so on and so forth, right? Let's see what is the count for. So I'll also print the release year altogether. And if you run the code now, can you see the number of movies released in 2019, 44, 2018, 24, 2017, 110, so on and so forth. So what's going on here? This group by clause actually converted your sparse or distributed data and grouped them based on one property. You can group on multiple properties also. So the moment your queries start becoming complex, you can group on multiple properties as well. So you start grouping them based on release year, right? So there will be one group of release year 2019, one group of release year 2018 and so on. And then on this group, you can do some particular operations. For example, you can count how many elements are in the group, right? And then also print this count belongs to which group. Now the identity of this group is belonging to the release year. This is the group of year 2019. This is the group of year 2018, right? If you will try, for example, in the film, let's see, column is title. A very interesting thing that you can try is if you try to print a title, no, let's say along with the count of the group release year, let's say you think that, okay, let's print title. This is actually going to throw you an error. Can you see it actually throwed you an error? Why it throwed you an error? Because title is not the property of the group. Because in a group, there can be multiple titles. Title doesn't give any individualization to the group. The release year is the individualization of the group. The count is the individual, like every group has how many elements. So that can be a group property. But title is not the property of the group. Title is the property of individual elements. So whenever there is a property of individual element, you cannot print them directly in a group by. So that's how you actually do something like count star, right? And you can see you are able to count all of them here. But now let's say I don't want the count of everything. Let's say I don't want the count of everything. Let's say I only want the count of the year 2019. So the first thing that might come to your mind is that I'll say where, let's say, I'll put it in a new line, where release year equal to 2017. Okay, can you see it's already throwing a compiling error? Where is not at its valid position. That means after a group by, it's not able to put a where. That after grouping, you cannot put a where directly. That's a problem here, right? That where was the only clause that we were having to filter out the data. But now once we have created groups and we said that group by works on the group property instead of the individual property, release here is a group property, right? But where is not applicable here. Now, why is that? Because in these kind of aggregated methods mean the method that is applied on kind of like a group. Instead of where, you have a clause called as having. You can see now there is no error. And now if you execute the code, can you see we are just getting the data for 2017. So with group by, instead of where, like if you have to query or filter on a group or on an aggregated data, then you use having. Whereas in your normal data, if you want to just filter out, you use where. And group by is going to group a collection of data based on a particular property, and then you can only fetch out the group properties instead of the individual properties altogether. That's the use case of group by that comes very, very handy in a lot of queries. So now in case, let's say if you want to alter the structure of the table, let's say you want to add a column to the table, or let's say remove a column from a table. Let's say you have prepared the table, now you want to change the structure of the table. How can you do that? So what we can actually do is there is a alter table command. You can do something like alter table and then name of the table. So let's say theater. And then let's say if you want to remove a column, you can say drop description. And that's it. You execute this code. You can see it executed fairly well. And now if I refresh, can you see the description column is not available at all? And let's say if you want to now add this column, so alter table theater, you can say add description, right? And then you can give the type and let's say the corresponding, you can say values, like I would say attributes or something. So let's say this was of type text and let's say not null. Okay. Now if you execute this command, you can see it executed well. And then you can say describe theater. Can you see you have a description and the null value is no again, right? How cool is that? So that's how you can actually make changes to the structure of the tables altogether. So technically, if you see whatever we have been discussing up till now, this was making a lot of sense, right? But there is something more interesting stuff that comes with SQL. Let's say if I do something like, okay, now let's say this is all of the data that is coming up, right? Let's forget let's just see this much data: title, description, release year, and everything. Let's say at any point of time we have to update some data. If you have to update some data, then we have to first of all know, right, that that data is located where. For example, actually what happens here is that all of this data is actually stored in our disk. Actual disk, hard disk is there where this all of this data is actually stored, right? And whenever you actually query, so what internally goes behind the scenes is that there is something called as a disk block that actually keeps on reading the data inside this disk and fetches the data for us. Just think about it like this. Let's say instead of SQL, you would have got a JavaScript array. Inside that array, you want to update, in that array is an array of objects. That array of objects, you want to update a particular object. In order to update a particular object, you need to first of all fetch that object. How do you fetch an object inside an array? You iterate over all of the objects, and then based on some property, you actually check whether this object is equal to the object that we are finding or not, whether this object is equal to whether the object we are finding or not, and so on. Isn't that true? Right. Now, how that thing is actually done in SQL? Like, for example, let's say I want to update this movie with the name, let's say African Egg. So there can be multiple movies with the same name, right? You know that in, let's say, South India and Bollywood, like, let's say Tollywood, like how the I guess segregation is, there's a Tollywood, there is Bollywood, Hollywood, right? Different media industries are there. People have same name movies like Dawn. It's the same name movie altogether, right? So the problem is that multiple movies can have same name. There's a chance that they might be having same description, same release year as well, right? So which property you are going to actually use in order to identify a particular record uniquely? That's a problem here, right? So the problem statement is that in SQL, do we have a provision using which we can actually identify a particular record uniquely? So yes, there is a provision using which you can identify a particular record uniquely. This provision is called as keys, K-E-Y, keys. So keys is kind of like one or more columns which, if combined together, if let's say there are more columns than combined together, if there is one column, then it is alone that can do the work for you, that these keys can help you to uniquely identify the data, right? For example, in this case, forget about the ID for a moment. I believe that title, release year, and language ID, this can be something that can be used, because in Bollywood, people will not make the same movie with the same name again. Probably, I'm assuming, right? There can be a case that in Hollywood and Bollywood, there were two movies with the same name, but still they will be having a different language. That will be in English, this will be in Hindi, right? So logically, you have to see how the data is represented, and maybe with a one column or a collection of columns, you can actually uniquely identify your data, right? Now, sometimes in a few tables, to make things easy, there are different type of keys. Okay, there are different type of keys. So to make things easy, we generally have, most of the time, like 99.99% of the time, in most of the tables that you will prepare, you will be having a key called as a primary key. This primary key is very, very, very important. Why? Primary key is a single column generally, right? Or sometimes it is a single column, sometimes it is a set of columns also. Single or a set of columns that can uniquely identify your data, right? For example, here, title, description, and language ID together can form a primary key. But apart from that, if let's say every film has a unique film ID, then we don't need three columns together. We can just have the film ID that can be qualified as the primary key for us, right? As simple as that. Let's say instead of film, we call as film actor. Okay, let's get the data of film actor. If now you execute this code, now you can see in film actor table, there is no film actor ID. There is no unique ID or column like that. There is an actor ID and a film ID, actor ID and film ID. Now in this case, what's the primary key? The primary key is going to be the combination of these two columns, actor ID and film ID together. That's the primary key. This is something that is very important that you have to understand, right? A very important property about primary key is that primary key can never be null. Primary keys can never be null. You have to always keep this thing in mind. That is why when we were actually creating that particular, I would say, table, right? Here you can see the moment, let's say if I drop the table theater, okay? Drop the table theater. And then let's say I create a table theater here. And then I describe theater. Can you see I have not given any primary key to the theater? So you can see there is no word primary key written here. But still, if you see the ID property, there is a key column coming and it says PRI. Why it says PRI? Because this ID is a non-null value and it is unique for every record. So the moment you have a column that is unique for every record and can never be null, that automatically makes it a primary key. If you don't want to make it primary key like this, what you can actually do is you can separately give at last of all of your columns, you can say something like primary key, and then you can mention what column you want to qualify as a primary key. Right. Otherwise, you can just give that column not null and unique and it will automatically become primary key. So this syntax, something like this, you can actually use as well. Right. And primary key is one of the most strongest phenomena that you will actually find in ever in SQL. Right. Because primary key has the capability to uniquely identify the data. Now the thing is that, just think about it. If let's say we sort the data somehow, if in the memory, the disk actually where the data is stored, if somehow we can store the data in an organized way based on this primary key, and let's say this primary key is a number like film ID. Don't you think if we keep the data sorted in terms of film ID, now if somebody has to search for a film, instead of going through all the records, they can maybe do a binary search, right? If we have all the records stored in sorted fashion based on the film ID, right? Based on the film ID, if all the records are sorted in a stored in a sorted fashion, right? So what will happen is you can actually apply binary search. So the query that was going for order of n will be improved to order of log n, right? So there are provisions in SQL using which you can, instead of your normal, like this is a normal table, right? In a normal table, things are arranged in the order in which they are inserted. But let's say you want to order them something else. For example, let's say you want to order in decreasing order of film ID, or let's say you want to order them based on decreasing order of last update, some specific property you have. So there is a provision called as indexes. These are extra data structure. It will take extra memory in your disk, which will be prepared based on any of the particular values, which will store the data in a particular way for making sure that your queries are efficient, right? Generally, internally, this is implemented in using tree data structure with a very special tree called as B plus trees. You can read about it, but technically for dev purpose, you don't need to go there because databases are already lot optimized. My point being that keys can be very powerful, and primary key can help you to actually uniquely identify your data. That's the best part about primary key. Okay. Now there is, sometimes people can ask you what is a candidate key. That this is also some, like there are 2-3 type of keys. I'll mainly name the major ones. So there is something called as a composite key. There is something called as a candidate key, right? There is something called as an alternate key, and there is something called as a foreign key. If I talk you with respect to interviews, in an interview, if let's say the interviewer is a lot theoretical guy or a girl, they might ask you any kind of a key. But I will tell you with perspective of a software engineer. It's been quite some time I've been doing coding, building products and everything. Trust me on one small part. The concept that you need to forever remember is primary key and foreign key. Remaining, even if you don't remember, you can, and you want to use them at some point of time, you can use them on the fly, Google about it. But this is something that if you will remember, that will actually help you in development work as well. Right. Now let's go through one by one all of them. Okay. Generally, primary key, as I mentioned, that it is a single or a set of columns to uniquely identify data, right? This primary key, when instead of a single column, there's a set of columns that uniquely identifies a data. That is sometimes also called as a composite key, right? So every composite key is a primary key, but not every primary key is a composite key, right? So you can say that those primary keys which are a set of columns instead of individual ones. Okay, so this is also kind of like a primary key altogether, right? So this is a key that consists of 2 or more columns to uniquely identify a row in a table, right? When is this used? For example, when I showed you film underscore actor. Okay, so here technically these two as a combination of together kind of like a composite key altogether, right? Okay, so a lot of time, like actually people do get this confusion that uh, primary key is also a set of columns can be there, composite key is also there. So for logical difference, for actual development purpose, you can keep this thing in mind that generally primary key is a single column Composite key is a set of columns, but every composite key is also a primary key, because the basic definition of primary key is to uniquely identify, right? Cool. Now there is something called as a candidate key, right? There is something called as a candidate key. So now, as I said, for example, in our film table, film ID was also a primary key, and there were some more set of columns that can act as a primary key, right? There were multiple provisions of a primary key, or I would say we had multiple options to pick a primary key, right? So you can say that candidate keys are the, like, let's say for our purpose, if I consider film ID as the primary key, you can say candidate keys are all those columns that can qualify as a primary key, right? So again, not a very useful information. All those columns that can qualify as a primary key, kind of like this, right? So again, things boils down to primary key altogether, right? What's the alternate key? Candidate key not chosen to become the primary key. Again, everything boils down to primary key. Alternate key are those columns which we ignored, which could have been the primary key, but we ignored for our use case, right? Candidate, what is a candidate key? All those columns that can become primary key. We can have multiple primary keys in our table. All those columns that can become primary key are candidate keys, right? And but let's say for our use case, we'll pick any one. So all the ones that are neglected are the alternate keys. So you can see, in actual purpose, in actual theory, you are not going to use much about it, right? But then comes foreign key. This is important. This is important, right? It refers to a primary key of another table inside a table, right? So let's say you have a table X, and table X has a primary key P, and you have another table Y, and inside the table Y you have the primary key of the table X stored. For example, let me show you. If I do select star from film, can I say film ID is the primary key here? You can actually check also. Describe film. Film ID is the primary key, right? Now, if you actually query for film actor, can you see film actor table has a column film ID? Just this column film ID is not the primary key for film actor, right? But this column film ID is a primary key in film table. So this film ID inside film actor is a foreign key. Film ID inside film actor is foreign key, because it is a primary key in other table, right? So if I let's say if I do film actor, see film ID and actor ID, right? So they are primary key in another table, because just film ID cannot actually help you to uniquely identify a record, right? You can see multiple actors can be there in the same film. Multiple actors can be there in the same film, right? Let's try to even see that. Are there multiple actors in the same film? So let's say if I do select star from, or let's not do select star from, let's do let's select count star, comma, film ID, and let's say we will do a group by film ID. Let's run this query. Can you see in the film ID 1 there are 10 actors actually, so there are 10 records. Film ID 2 has 4 actors, so just film ID cannot uniquely identify the record, right? So both of them together will identify. So that's why this film ID inside film actor table is a foreign key. This is something that you have to keep in mind always.